So guys, last meeting, I started with introduction for our course. Introduction to Structure Analysis and Design course. I started with what are the types of structure we will learn in this course. We have three main structures: beams, frames, trusses. Also, I talked about what is the meaning of internal forces, straining action, shear force diagram, bending moment diagram. These internal forces will cause deflection and also will cause stresses. In this course, we will cover straining action and the deflections in more detail. Also, I covered what are the types of loads. We have main two types: vertical load, horizontal load. Any structure will have two main types of load: dead load and live load. Probably and sometimes you can find snow load in Texas or Florida or whatever the state. Probably we don't have this type of load, snow load, but in the mainly we have at least two types of load: dead load, which is the weight of the structure itself cannot be moved, and we have live load, which is movable. You can move the position, the location of this load. Horizontal load, probably like earthquake, like wind load, like earth pressure, like water pressure. We have four shapes of load. In our problems, you can find concentrated load, only 1 point load. You can find something called concentrated moment. We have something would like to rotate at a specific point. Probably you can find line load, vertical load or horizontal load at a line like this one, like this wall. This wall represents a line load. Probably we have surface load on area, not line, not point, but area. All of this stuff covered last meeting. Before starting our meeting today, do you have any question? Okay, looks good. I have question. For this structure looks like a concrete or steel structure. I would like to explain something very important. We have something here called slab or concrete slab. Then we have something here called beam. And this one also called beam. I have question: what is the main difference between this brown beam and this green beam? Both of them are beams, but what is the difference between this one and this one? Actually, the main difference is the brown beam can be called secondary beam, and the green one can be called main beam, main girder. The green beam is supported by this column and this column. And then the vertical column is supported by this foundation or this footing. I forget The secondary beam, which is in brown color, is supported by what? This is a question. I need answer. Can you tell me this brown secondary beam is supported by what?
The main beams.
Yes, the green beam, which is the main beam. Thank you. So keep in your mind, for any concrete structure or any steel structure like this, I can say this slab is supported by secondary beam and the main beams. Then the secondary beams is supported by this main beams. And the main beams is supported by vertical column. And finally, the vertical columns is supported by foundation. This is called a statical system. The sequence of load. The sequence of loading. So, keep in your mind, this secondary beam will cause concentrated load here. This secondary beam will cause concentrated load here. That makes sense. Because this secondary beam is supported by this main beam at this location. That makes sense. And finally, this main beam is supported by this column and this column. And finally, the column is supported by this foundation and this foundation and this foundation and any other foundation. Any question so far? Any question so far? Okay, looks good. I have another question in this point. So, on this rectangle, can you watch this rectangle? We have secondary beam, this one and this one. We have main beam, this one and this one. Between these four beams, we have a slab, concrete slabs. What do you think? This slab is supported by the four beams or only two beams? And which two beams? Do you think this slab in between the four beams is supported by which beams? The brown ones or the green ones or all of them? What do you think? Yeah, I understand that the brown beam is supported by the green beam. The secondary beam is supported by the main beam. That's fine. I understand this. No, I'm talking right now about this slab. Is supported by which beams? Secondary beam or main beam or both of them? What do you think? Guys, what do you think?
Both of them.
Both of them.
Both of them.
Any other question? Any other answer? Both? All of them? Two of them? Or it depends. So our topic today will be about types of slab, concrete slab. Sometimes your slab can be called one-way slab. Sometimes can be called two-way slab. So your answer for my question is not all of them or not both of them. No, your answer will say It depends. What is the type of this slab? If this slab is one way, I believe the brown beams will support only. If this slab two-way, both of them, the green and the brown beam will support. Let me explain it in more details here. So I have a slab here. This slab is supported by this beam and this beam and this beam and this beam. I would like to understand what is the portion, or what is the part, or what is the area assigned to this beam, beam number 1, beam number 2, beam number 3, and beam number 4. Do you think this slab is supported by the 4 beams, or 2 opposite beams, beam number 1 and beam number 3, or beam number 4 and beam number 2? What do you think? It depends. What is the type of slab? One way or two way? How can I figure this out? It's very easy. Pay attention, please. For this slab, we have this dimension and we have this dimension. Probably one of them is longer dimension and the second one will be shorter dimension. I'm talking about rectangular slab. If you divide the longer dimension by the shorter dimension and your answer is greater than 2, you are talking about one-way slab. If the longer dimension divides shorter dimension smaller than or equal to, that means it's a two-way slab. Very easy, very simple. Please, if you go back to this structure, for this rectangle that I'm talking about, this rectangle has 2 dimensions. This dimension which is shorter and this dimension which is longer. Please divide the longer by the shorter dimension and let me what is the answer. If your answer greater than 2, this rectangle will be one-way slab. If the answer is smaller than 2 or equal, this rectangle will be two-way slab. Based on this answer, you can figure out which beams are supporting your slab. That makes sense? That makes sense?
Yes.
Okay. So let's first start to watch this video and see what is the meaning of one-way slab.
This one-way slab is supported along 2 parallel edges and bends in one direction only. The red arrows show the transfer of the applied loads from the one-way slab to its supports. This one-way slab is supported along 2 parallel edges and bends in one direction only. The red arrows show the transfer of the applied loads from the one-way slab to its supports.
So if you have a one-way slab, that means we have one-way means the load of this slab will move only in one direction, to your right and to your left. We have only one way to support this slab. if the longer divided shorter is greater than 2, any load of this slab will be supported by one direction to this side and the other side. We don't have any support to the top and the bottom in this direction, only one direction. Can you watch the arrows?
One-way slab is supported along two parallel edges and bends in one direction only. The red arrows show the transfer of the applied loads from the one-way slab to its supports. This one-way slab is supported along two parallel edges and bends in one direction only. The red arrows show the transfer of the applied loads from the one-way slab to its supports. This one-way slab is supported along two parallel edges and bends in one direction only. The red arrows show the transfer of the applied loads from the one-way slab to its supports.
So, if we have one-way slab like this one, we have rectangle here. And you divide, we have the rectangle, we have beam number 1, we have beam number 2, we have beam number 3, we have beam number 4 around this rectangle. What do you think? If the longer divide shorter greater than 2, then the weight of this slab, the load on this slab will be transferred only in the shorter direction. This one and this one. This one and this one. We can draw a line here at the midpoint for the shorter direction, and have the slab will be supported by beam number 1. The other half of the slab will be supported by beam number 2. We don't have any load from this slab to this beam or this beam. So we have only 2 beams supporting this slab, and the other 2 beams do not. Any question so far? If you have any question, let me know. Okay, please, what will happen if you have two-way slab? What will happen if the longer divide shorter, smaller than or equal to? Go ahead and watch this video.
Because this spatial structure bends in two directions when loaded, it can be idealized as a two-way slab.
One more time.
Because this spatial structure bends in two directions when loaded, it can be idealized as a two-way slab.
Let me explain it. We have 4 beams around this rectangle or this square. So the load of this slab will be shared by 4 beams, to right and to left, to top and to bottom, like this.
Because this spatial structure bends in two directions.
Can you see? We have a part supported by this beam. We have another part supported by this beam. We have another part supported by this beam. We have another part supported by this beam. The 4 beams around this slab will support a part. Each beam will support a part of this slab. That makes sense? I believe that makes sense. So why it's called two-way slab? Because the load will move in two opposite directions, to right and to left. This is the first direction, and then to top and to bottom. This is the second direction.
When loaded, it can be idealized as a two-way slab.
So if you have a rectangle like this one, or a square, whatever, and we have 4 beams, beam number 1, beam number 2, beam number 3, and the beam number 4. And you divide the longer by shorter, and your answer is smaller than or equal to, then your slab will be two-way slab. That means we have a part of this slab will be supported by this beam, beam number 3. We have another part supported by beam number 4. We have another part supported by beam number 1. We have another part supported by beam number 2. Each beam will support a part of this slab. So your slab load will be moved in this direction and also in this direction. So we call it two-way slab. This one is moved only in one direction. So we called it one-way slab. We don't have this direction. This direction does not exist. The load does not move in the horizontal direction, only vertical direction. So we call it one way. But this one, we have two opposite directions. So we call it two-way slab. Did you understand this concept? Because this concept is very important. For any concrete slab, we have two types, one way, two way. It's very simple. Just divide the longer dimension by the shorter dimension. I can tell you what is the type of this slab. Is it one way or two way? Okay, I understand this point. How can I determine what is the portion assigned to this beam and the area assigned to this beam and the area assigned to this beam and the area assigned to this beam? If we are talking about two-way slab, it's very simple. At this corner, please go ahead and draw a line with angle 45 degree. Another line with angle 45 degree. Another line with angle 45 degree. At this corner, draw a line with angle 45 degree. Extend these lines, these lines, these lines, these lines. You can draw an envelope like this. Once you draw this envelope, we can say, hey, this part of the slab will be supported by beam number 1. This part of the slab will be supported by beam number 2. This part of the slab will be supported by beam number 3. This part of the slab will be supported by beam number 4. Does that make sense? I think that's fine. Okay, one more time. So guys, we have a rectangle like this. This direction is 10 feet and this direction is 15 feet. So if you divide longer by shorter direction, we have 15, divide 10, your answer will be 1.5. I believe 1.5 is smaller than or equal to. This slab will be two-way slab. I would like to determine how much will be assigned to this beam, how much will be assigned to this beam, how much to this beam, and how much to this beam from this slab. Okay, it's very easy. At this corner, draw a line with angle 45 degree. Draw a line with 45 degree. Draw a line with 45 degree. Draw a line with 45 degree. Extend this line, This line extend until intersection and then complete this envelope. I am done. This part of the slab is assigned to this beam, beam number 1. So beam number 1 looks like this. Here is the beam, supported here and here by a column at this location and the column at this location. And this beam is supporting a trapezoid like this. The other beam, beam number 2, the same. This part of the slab, which looks like trapezoid, is supported by beam number 2. For beam number 3, we have this triangle. If you would like to draw this beam, looks like this, supported here and here by this column and this column. This beam is supporting a triangle like this. And it's the same also for beam number 4. This part will be supported by beam number 4. That makes sense. Question? No? Okay. Guys, please be careful. So the question right now, do you think all the time your distribution will look like envelope, 2 trapezoid and 2 triangle? All the time? What do you think? Let's see if you have this shape of a slab. We have beam here, we have beam, we have beam, we have beam. 4 beams and the 4 columns. We understand that the beams are supported by columns. That makes sense for me. This dimension is 10 feet. This dimension is 10 feet. So this shape is square. Okay, I don't care. Square or not, I don't care. So longer divide shorter equal. Which dimension is longer? Which dimension is shorter? I don't know. So I will assume the longer one will be this one, the shorter one will be this one. So 10 divide 10 equal 1. That's fine. 1 is a number smaller than or equal to. That's fine. So your slab will be 2-way slab. That makes sense. That's fine. Because you told me divide the shorter by the longer by the shorter and figure out what is the type of slab based on this relation and this relation. What is the problem? We don't have any problem. But if you draw here a line with angle 45 degree and another line with angle 45 degree and another line with angle 45 degree, and you extend these lines, you can find we have 4 triangles. This triangle assigned to this beam, and this triangle assigned to this beam, and this triangle assigned to this beam, and this one assigned to this beam. So for 2-way slab, you can find this envelope shape if you have rectangular shape and longer divide shorter, smaller than or equal to. Or you can find this shape if you have square slab. Longer divide shorter equal 1, smaller than or equal to, so it's a 2-way slab. But if you draw the line with 45 degree, you will divide the slab to 4 triangles. In this case, you divide the slabs to 2 triangles and 2 trapezoids. Any questions so far? Guys, let me know Do you have any question so far? This point is very important. For example, in the exam, someone or one student will say, hey, any two-way slab, I will divide it to this shape, two trapezoid and two triangle. However, I give you a square slab and you draw this shape, you will get 0. Be careful. Be careful. If you have two-way slab, we need to draw 45 degree, 45 degree, 45 degree, 45 degree, and extend. Probably the final shape looks like two trapezoid and two triangle. Probably the final shape will looks like four triangles. It depends on, do you have square or rectangular? Looks good. Looks good. We are walking slowly. I would like to start with example number 1. We have steel framework is used to support the reinforced concrete slab that is used for an office. The slab thickness is 200 millimeter. Sketch. The loading that acts along member BE. Where is BE? This one. This one is BE. And member FED. FED, this one. F, dimension A, 2 meter, 2 meter, and the dimension B is 5 meter. Okay. Let me explain something very important. This beam is called secondary beam. And this beam can be called main beam or main girder. Why? For one reason. Any beam needs supports. What are the supports for this beam? Tell me. Do you have column to support this beam? No. So what is the support or what are the supports for this beam? This beam will be supported by another beam at this location. So this beam is supported by this beam at this location. So we have secondary beam and we have main beam. That makes sense? That's right? Okay. So where is the rectangular shape? Do you have a rectangular shape? Yeah. Let me draw this shape as plane like this. Something like this. So this dimension is 5 meter. 5 meter. We have another beam here. I'm sorry. Wait. Like this. So we have column, and another column. F, E, D, A, B, C. This dimension, which called B, equal 5 meter. This dimension is A, equal 2 meter. A, equal 2 meter. let me talk about this rectangle. We need only a rectangular shape surrounded by 4 beams. This beam, this beam, this beam, and this beam. Okay? So we have a rectangular shape supported by 4 beams. Please go ahead and divide the longer dimension by the longer dimension by the shorter dimension. The longer dimension will be 5 meters. The shorter dimension will be 2 meters. Guys, I will not talk about the whole rectangular shape. No. I'm talking about rectangular shape surrounded by 4 beams only. So which one is surrounded by 4 beams? This one, and this one, and this one, and this one. So we have this rectangle. This rectangular shape has a dimension of 5 and 2 meters. So the longer divide shorter is 5 divide 2 equal 2.5. I believe 2.5 is greater than 2. So we have one-way slab. One-way slab means this rectangle will be divided like this. Half of this slab will be supported by beam BC. BE. And the other half will be supported by beam AF. The same sequence for this rectangle. Longer divide shorter is 2.5, greater than 2 is one-way slab. So half of this slab will be supported by beam CD, and the other half will be supported by beam BE. Any question? If you would like to understand this from this isometric, I can say half of this slab will be supported by this beam, and the other half will be supported by this beam. Half of this slab will be supported by this beam, and the other half will be supported by this beam. Any question?
I have a question.
Yeah, go ahead.
From this, are we able to say that beam BE holds more load
Yes.
than the other?
Yeah. This is called loading of a structure. In concrete design and steel design courses, you will learn more and more and more about this concept. Yes, beam BE will support more load than beam C, D, and AF. That makes sense.
Okay, thank you.
Yeah. So, guys, if you would like to draw beam BE will be supported here and supported here. Any beam is supported at both ends. For beam BE, this support and this support will represent the main girder and the main girder on the other side. Anyway, this beam is supporting a rectangular shape, which is this area of a slab. Can you watch the black area? This one looks like rectangular shape of the slab. So the part supported by this beam BE, will looks like rectangular shape like this. From structure analysis or from engineering mechanics, this distributed load has equivalent. We will have reaction R1 and reaction R2, or R1 and R2 will be equal, so we have reaction R. So beam BE, which is this beam, will support this shape of load. This load will be equivalent to a force F, so we have reaction R and another reaction R on the other side. If you would like to represent beam FED, which is this one, this beam FED will be supported by a support here, represent this column at F, and another column here, which represent this column at D, and at E, we have concentrated load here, R. Wow. Why? What is the meaning of beam FED? Can you watch this isometric, please? Guys, can you watch this isometric for FED, for beam FED? At this location, we have support, which is this column. At the other end, we have another support, which is this column. So we have support here and support here. Can you tell me what is going on at E? What is the meaning at this intersection between this secondary beam and this main beam? We have a secondary beam supported by this main beam. So the reaction coming from the secondary beam will be supported by the main beam. So we have concentrated load here, or this are coming from this reaction of the secondary beam. Guys, do you have any load here or any load here? Do you have any part of the slab, any part of the slab directly goes to the main beam? No, no, we don't have, because this slab is one way, is going only to beam BE. So the final distribution, which you call the sketch, I would like to draw this plane. I would like to draw for beam BE this shape, and for beam FED this shape. One more time. This concentrated load R on beam FED is coming from the secondary beam BE at the intersection point E. This beam is supported by this beam. So the reaction from beam BE is supported by beam FED. Any question? Just sketch this example or this type of problems, asking for a sketch. Just a sketch. Tell me, what is the sequence of loading of this slab, one way or two way? And then go ahead and tell me what is the load assigned to beam BE and what are the loads assigned for beam FED. Based on your sketch, we don't have any load coming directly from this slab to beam FED. But we have only one concentrated load here coming from this secondary beam on this main beam. One more example. But before moving to example number 2, any question? Okay, one more time. We have steel framework is used to support the concrete slab. The slab thickness, I don't care. We need to sketch the loading that acts along member BE and the member FED if dimension A equal 3 meter, dimension B equal 4 meter. If you would like to draw this plan of a slab, looks like this. F, E, D, A, B, C. We have 4 columns at these 4 corners. These dimensions, 3 meter, 3 meter, and 4 meter. They are given. We need to decide where is your rectangular shape? I think we have this rectangular shape. We have this rectangular shape. What is the longer? Divide shorter. We have 4 meter, divide 3 meter. What is the final answer? 1.33. I think it's smaller than 2. I think we have 2-way slab. So two-way slab means at this corner I would like to draw line with angle 45 degree, another line with 45 degree, 45 degree, 45 degree. Please extend these lines to be intersected. If you extend these lines, you can form this envelope. I believe if you do the same for the other rectangular shape, this one, longer divide shorter is 4 divide 3 equal 1.33 smaller than 2. You are in two-way slab. I will draw the same. This line, this line, this line 45 with 45 degree extend. You can form this envelope. Then I can say this trapezoid will be assigned to beam CD. This trapezoid will be assigned to beam EB or BE. This trapezoid will be assigned to beam BE. This trapezoid will be assigned to beam AF. That makes sense? And finally, this triangle will be assigned to beam ED, and this triangle will be assigned to beam FE. And this triangle, the same for part BC, and this triangle for part AB. Any questions so far? It's very simple. This one is the first step. Very important. You need to figure out what is the type of a slab, one-way or two-way. Based on the configuration of the slab, I can lay out, I can draw, I can distribute the load of the slab? Triangles, trapezoids, or rectangles like this if the slab is one way. Any questions so far? You have any question, let me know. Okay, looks good. We need to sketch what is going on with beam BE. Beam BE, this beam. This beam. Beam BE looks like this, supported here and supported here by this main girder and this main girder. That makes sense. This beam is supporting a trapezoid like this. Two trapezoids. One from left, from this slab, and one from right, from this slab. Two trapezoids, whatever. So this load will represent a force like this. This force will give you a reaction on this support and a reaction on this support. That makes sense. This beam can be called BE. And this one is two trapezoids. It's not one, two. One from this side and one from the other side. We need to figure out what's going on with beam FED. FED. This beam. This beam is supported at F by a column, this column, and at D by another column, this column. At E, we have concentrated load R with a reaction R. This R coming from this secondary beam, which is this R. That's all? Guys, that's all for beam FED. You have answer? Do you think
No,
I am done?
no, it should have the load, the triangle load.
Thank you. Thank you. We still have this little triangle. This little triangle is assigned to this part. And we have another little triangle. This little triangle is assigned to this part. I am done. I am done. Does that make sense? Because I told you, if you have two-way slab, this slab is supported by this one and this one and this one and this one. And this slab is two-way slab, so it will be supported by this one and this one and this one and this one. So if you would like to draw this beam, FED, this beam will support a portion from the slab, like triangle here, and we have concentrated load coming from the secondary beam BE. I am done. This problem is very simple, and you will find one like this in your coming exam. I will give you an isometric like this and the dimensions, and I will ask you to sketch. It's very easy, very simple. One more example. Example number 3. The last one. We have a slab supported by trusses or whatever. We don't care, and we need to sketch. Just sketch without calculations. Sketch the loading that acts along the joints or the secondary beam BF. This one. And the main girder or side girder A, B, C, D, E. This beam. If dimension A equal 10 feet, and the dimension B equal 10 feet. So if you would like to draw a plane like this, we will have something like this, 1, 2, 3, 4. I believe to be more realistic. Like this. So we have A, B, C, D, E. We have, this one is F. We have 4 columns. And these dimensions will be 10 feet, 10 feet, 10 feet, 10 feet. And this dimension will be 10 feet. Where is your rectangular? Guys, it's a fatal mistake. It's wrong. If you say we have this rectangle with this red color. No, I cannot say this. Your rectangle or your square must be bounded by 4 beams or 4 boundaries. This boundary, this boundary, this boundary, this boundary. I cannot say this by these 4 boundaries. No, we have one here, and we have another one here, and we have another one here. So your shape will be this area alone. Be careful about this point. Be careful. Be careful. So your area, one area like this, we have longer, divide shorter, equal what? We have a square. That's fine. So which one is longer? Which one is shorter? We don't care. 10 divide 10 equal 1. This ratio smaller than 2. So we have two-way slab. If you have two-way slab, I will draw a line with 45 degree, 45 degree, 45 degree. You can draw 4 triangles in each one because it's a square. You are lucky. So this triangle will be assigned to this part. 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 The same here. And the same. And the same. Keep going. Keep going. All of these assigned area will be triangles. Be careful, don't draw an envelope because your area here is a square. This area is a square, so longer divide shorter equal 1. It's a two-way slab, but your distribution will be 4 triangles. Anyway, let me focus on beam BF. Where is BF? This one. What do you have for beam BF? Beam BF is supported by this main girder and this main girder. That's fine. And this beam or this secondary beam is supporting two triangles. This one is two triangles. And these triangles will give you a force. This force will give you a reaction. That makes sense. If you have a force, you have a reaction. Okay. I am done with joist BF. What about main girder or side girder ABCDE? This one. A, B, C, D, and F. E, I'm sorry. We have support here, which is this column at A. We have another support here at E, which is another column here. Be careful. We have concentrated load here at B. We have another concentrated load at C. We have another concentrated load at D. R, R, R. Don't forget, this secondary beam is supported here. This secondary beam is supported here. This secondary beam is supported here. So we have three concentrated load at these locations. Do you think I am done? Do you think I am done? No? We still have four triangles. We still have four triangles. This triangle, this triangle, I'm sorry. I'm talking about A, B, C, D, E. So this triangle, this triangle, this triangle, and this triangle. So we have four triangles. Here is beam A, B, C, D, E. Here is beam B, F. I am done with the load distribution, sketching the load that acts on BF and A, B, C, D, E.